All right, we've got one that's going to involve a little bit of logs here, so we're going to take the first antiderivative, which will give me the derivative, raising the negative 2 by 1, dividing by negative 1, plus c. Unfortunately, my initial conditions do not have anything to do with the derivative, which means that I need to take, before I can use them, I need to take the antiderivative a second time. So I'm just going to rewrite this one to be negative x to the negative 1 plus c. Now taking the antiderivative one more time, I get negative x add 1 to the 0 divided by 0. So something funny is going on because I'm trying to divide by 0. So I'm trying to mimic what you might be doing if you have written it this way. It's really easy to think, okay, I'm going to use the power rule. So what went wrong? Well, if I write the function that the derivative function like this instead, it might be more easy to recognize that the derivative that would produce that would have been a log function. So minus the log of x. And I don't have to worry about x being negative because x is the domain of the original function is positive. So negative log x plus cx plus d. So again, I've done this one, but don't forget to keep going. This has an x to the 0, add 1, and then introduce the second antiderivative constant, or constant of integration. So now I've got my equation for f of x, and I'm going to apply these two conditions to it to solve for c and d. So the first one is the y value is 0 when x is 1. So simplifying this, I get negative log of 0 is 0. So I get just c plus d, which means c equals negative d. There's my first equation relating c and d. So doing this again, I'm going to again apply the second condition. So y is 0 when x is 2. So that means I've got log of 2, I'm moving this over to the other side, adding log 2 equals, oops, not equals, plus, equals 2c plus d. So I've got two equations and two unknowns. Here's my first equation and here's my second equation. Now I'm going to solve these, and I think what I'll do is use substitution methods. So in other words, replace my c with a negative d here. So I get log 2 equals 2, this is negative d plus d. So log of 2 equals negative 2d plus d, which is equal to negative d. So I've got d equals negative log 2. There is my answer for d. And yes, you could change it to a decimal, but this is perfectly accurate to leave it in terms of natural log of 2. Now my last step is to figure out what c is. In order to figure out what c is, I know there's a relationship between c and d. There it is, which means c has got to be the natural log of 2. And so my last step is my putting it all together. My function is equal to negative log x plus x times the natural log of 2 plus, minus, because d is minus the natural log of 2.